Hello, my name is Mike from the Math Center here at Grantham, and this is part of our frequently asked questions series of videos. This one is for Finite Math, Math 170. This is going to be a problem similar to Chapter 1, page 22, problem 84 in the textbook, also similar to the Week 1 True or False assignment problem number 2. A quick general overview of the problem. The problem looks a little complicated at first, but just like a lot of problems in mathematics, if you break it down step by step, you find that it maybe is not quite as complicated as you thought in the first place. It's a good problem also in that it tests your knowledge of what the slope of a line is. It gives you an opportunity to practice your skills in translating a problem from kind of an English language format to a mathematical format to solve it. Then you have to do just a tad bit of algebra and some fractions. So, a good problem in a lot of ways. Let's just read over the problem real quick. Suppose the slope of a line L is minus 4/3, and P is a given point on L. If Q is a point 7/2 units to the left of P, then it's asking us to find where Q is situated in relation to P. Then Q is going to be so many units above or below P. So to get started, what we're going to do is we're going to start translating this problem, kind of going from left to right, kind of translating this problem into mathematics. So the slope of a line L is minus 4/3. As you may recall, as you should recall, slope is equal to sometimes called the rise over the run, or in symbols, delta y over delta x. Now remember that these symbols, delta y, delta x, just means change in y and change in x. And you treat these as a single variable. Even though they're two symbols, they're like a single variables. But we actually know what that ratio is because given in the problem, it's minus 4/3. All right, so now we have the slope of a line. Now I've got, at this point I think it'd be best to do a little picture. And it's always good to do a picture whenever you can. In a mathematics problem, it many times will simplify and give you insights into the answer. So what I'm going to use to create my line, I'm going to create a line with slope minus 4/3, and I'm going to use this little program called GeoGebra. This is a free graphing and geometry program available at geogebra.org. So what I'm going to do is just kind of pick an arbitrary point in this plane here, and just to make things clear, I'm going to make sure I'm at the crossroads of some of these grid lines. So I just plopped a point down, point A. And now I have to figure out, I need to create a line with slope of 4/3. Now realize I could have picked any point in the plane. I just kind of randomly picked that one. So there's really an infinite number of lines of slope minus 4/3, but once I've picked a point, there's only going to be one. Now to pick our next point, I want to go back over to my graphing program and point out something that you may recall. When I look at this fraction, minus 4/3, realize that that is equivalent to minus 4/3. All right, so the way we can look at this now is, all right, since I don't have anything out front, slope is delta y over delta x. So delta y equals minus 4, and delta x equals 3. As we go back to our graphing program, that's going to be useful because what's delta y? Delta y is change in y. And remember, the y direction is up and down, with positive going up and negative going down. So my next point I'm going to pick on this line is going to be 4 units down, 1, 2, 3, 4. But then I also have to take into account delta x, which is a positive 3. The x-axis goes left and right with positive to the right. So if I go down 4, 1, 2, 3, 4, go over 3, 1, 2, 3, I get another point. And then if I use this little tool to put a line between the two, I have a line of slope minus 4/3. Now this is, again, an arbitrary line. The problem doesn't give us enough information to pick out a specific line. This gives us a picture we can work with. I'm going to hide the points A and B. They're not really part of the problem, just part of drawing the graph. And I'm going to get this graph over to our drawing program so we can continue. And a little big, so I need to reduce it down. And there we go. We've got a slope of minus 4/3. Now, next thing I'm going to do, so let's just kind of go over what we've done so far. I've kind of taken care, kind of translated this part of the problem into mathematics, both looking at the algebraic definition of a slope and giving us an example of a line with a slope of minus 4/3. The next part of the problem says P is a given line on L. So I'm going to pick, I'm sorry, P is a given point on L. Misspoke there. So I'm going to pick a point, kind of arbitrarily, but for convenience sake, one that's close to the intersection of some of these grids. So I'm going to pick a point right there in my drawing program here. I'm going to call that point P. All right. Now, let's take a look at what this next part says. This next part says that Q is a point 7½ units to the left of P. What exactly does that mean? Well, what it doesn't mean is 7½ units like going along the line itself and measuring out 7½ units along the line. What it means there is the x-coordinate of the point Q is going to be 7½ units to the left of P. Now, let's think about this as we go in terms of, whenever you see a number in your word problem, you want to try to translate that number into algebraic symbols so that you can use them later. We've already got the 4/3, that was the slope, but 7½ thirds to the left, all right? Well, to left and right is the x-coordinate. So the only variable we got corresponds to the x-coordinate is, of course, delta x. And this delta x is going to be equal to 7/2, but 7/2 to the left, so it's going to be minus 7/2. And we're just going to hold that fact there for a little bit, okay? Now, that minus 7/2, okay, let's go down to the graph and think what this means. It means that the x-coordinate is going to be 7½ units to the left. And, 7½ units, if we switch that into a mixed fraction, is what, 3½ and remember, this notation back from grade school means 3 plus 1/2, not 3 times 1/2. So now going back down here to P then, if delta x is minus, which means left, 7½ units, or 3½, I have to go 1, 2, 3½ right there. And that's going to correspond, kind of a tick mark. It's not the point Q, it just kind of corresponds to the x-coordinate of my point Q. Now what I'm going to do is just draw a little line. I'm going to try to draw a perpendicular line from that little point up through line L. And there it is. So that means that our point Q is going to be right about here. Now, at this point, we can kind of solve half of the problem already. We've gone, oh, and by the way, I wanted to point out here that then this distance right here, corresponds to delta x. It's 7½ units to the left. So then that means that this change right here corresponds to our delta y, that distance right there. Now, one of the things we can see already is that if I go 7½ units to the left, then my Q is going to be above my P. So half of the problem's already solved for us. 7½ units above P. Now we kind of try to count out how much this delta y is, But let's stop for a second there and do it algebraically. So let's go back down over here and say that I'm going to recopy delta y over delta x is equal to minus 4/3. All right, so well, what we're looking to solve for in this blank up here is so many units above or below P. Well, above or below, again, is the y direction. So what variable corresponds to the y direction? It's delta y. So we have to solve this little equation for delta y. So I'm going to rewrite this left-hand side, delta y over delta x. And to solve for delta y, I have to multiply the left-hand side by delta x. Right? This will actually cause delta x to divide into delta x, become 1, leaving just delta y. Oops, wrong color. Just leaving delta y on the left-hand side. But up here, whatever I did to the left-hand side, I got to do to the right-hand side, so that's minus 4/3 times delta x. By doing the same thing to both sides of the equation, I didn't change anything. But we also know, and I'm going to recopy the minus 4/3 here, and I'm going to put parentheses around it to show the multiplication. We know that delta x is actually minus 7/2. So minus 7/2. So doing the multiplication, I've got a single minus sign over here and a single minus sign over here, so there's 2 minus signs total. That's going to make this fraction positive, and it's going to be positive 28 over 6. And if I divide 2 into both the numerator and the denominator, I get this as 14/3. So I have delta y equals 14/3. And again, if I wanted to help look at the graph, change that into a mixed fraction. 3 goes into 14 4 times, leaving 2 left over, so 4 and 2/3. Remember, that's 4 plus 2/3. And so now let's go over and take a look at our graph, and we see that, well, this point Q, if we go from P over 7/2 to the left, delta x, then point Q is going to be 1, 2, 3, 4, and about 2/3 above. The fact that this sign is a positive here, not a negative, corresponds that we have the correct picture, because our picture tells us that the delta y is in the positive direction. So that's it. And again, it was a complicated problem, broke down step by step. Actually, I think had a fairly easy solution. If you have any concerns or questions, if any of this you need any help with us, you can contact Math Center at grantham.edu. We're here to help. Thank you so much.